I like to be my own electrician whenever I need to fix some small connections at home. As you can see, these are copper wires being used to send electricity through household appliances like this lamp. Now tell me, do you think we can use the same copper wire to transmit electricity over long distances? Let me try this. Wow! If you think you can't use copper wire to transmit electricity over long distances, then can you tell me why? Meet me in the studio and I will tell you why and much more. Hello and welcome. I am Shaleen, your guide to the world of physics. If you are uninitiated into electricity, the concept of which material is used to transmit electricity and why could be mind-boggling. If you are one such person, then you're at the right place to know more about this. Electricity is governed by a few fixed laws, and the most important amongst them is Ohm's law. In today's episode, we will study Ohm's law, understand the concept of resistance and resistivity, and prepare you for your exams in the Exam Decoded. If you've ever gone camping in a forest or been through a power failure in a city like this, you would know about an electric torch. It's a device powered by electric cells that emits light and drives away all the spooky things that we imagine live in a dark room. Now, after some time, the light of the electric torch becomes dim and we say its cell has become weak. What do we mean by that? What happens is that by constant usage, the potential difference across the terminals of the cell reduces. For example, a new 1.5 volt dry cell generates a potential difference of 1.5 volts across its terminals. But when the cell is used for a long time, the potential difference drops to a smaller value, say 0.75 volt. When such a cell is used in a torch, less current is drawn and hence it produces less light. This is an important observation. It means that the electric current passing through an element, in this case the torch bulb, depends on the potential difference applied across it. The relationship between potential difference and current was first established by a German physicist, George Simon Ohm, hence Ohm's law. Now let's state Ohm's law. The current through a metallic element is proportional to the potential difference applied between its ends, provided the temperature remains constant. To better understand Ohm's law, let us consider this diagram. If a potential difference V is applied across a conductor, a current I is produced through it. We observe that this electric current produced through the conductor is proportional to the potential difference applied across it. Greater the potential difference applied, more is the current produced. Or we can say the same thing in a formula. V is equal to IR, where R is a constant for the given element and is called its resistance. But what is resistance? Physically speaking, resistance is the opposition offered to the flow of current through a conductor. Now, this arises due to the collision of electrons with each other and with the ions during the flow. The extent of opposition that is offered decides the resistance, which in turn decides the rate of flow of charge or current through the conductor. Also, we should note that if we keep the voltage V fixed, larger the resistance of the material, smaller is the current. A good conductor has low resistance, whereas an insulator has a high resistance. Applying Ohm's law, we can get any of the three values if we know the other two. For example, if we know the voltage and the resistance, we can calculate the current flowing through the circuit, or estimate the resistance if we know the voltage and the current, or calculate the voltage using the values of the resistance and the current. Now, this is an important feature of Ohm's law. You can be sure to find a numerical based on it. For materials that follow Ohm's law, the current and voltage are proportional to each other. So plotting V and I on a graph, we get a straight line with a positive slope. Since V is equal to 0 implies I is equal to 0, so this graph passes through the origin. Note that the slope of the straight line gives I by V, which is 1 by R. When we rearrange the equation to get the value of the resistance, we get R is equal to V by I. Thus, the SI unit of resistance should be the unit of voltage divided by the unit of current. That is, volt by ampere, which is called ohm and is denoted by Greek letter omega. Now we have a student with a query. Let's hear what the question is.
My name is Bharti and I wanted to ask that certain metals like copper, aluminium offer less resistance. What gives them this special property?
Good question. The student wants to know, why do certain metals like copper and aluminium offer less resistance? What gives them this special property? The answer to this question, well, you will have to wait for that one until we come back from the break. So see you shortly. You stay tuned.